Yes. Yes, now Arun sir, you can start the session, sir. Yes, students, we will unmute when you have doubt. We will give you the permission. Okay, we will give you the permission. Don't worry about it. Okay. You will be having interaction also. Don't worry about it.
Thank you, ma'am.
Yes, sir. Thank you.
Hello, students. Hello, everyone. Hope you're all doing good. Welcome to the next day of the session. All right, students. Today we'll quickly revise what we have done yesterday, and then we'll go forward with the class. All right. So let's get started. Here we talked about a number line. We have a number line. This number line is drawn as a tangent to a unit circle. So radius of the circle is 1. All right, 1 unit. So this new number line is drawn as a tangent to the unit circle, now wrapped around the circle. So we wrap this number line onto the circle. This way, further, and on the circle. All right. I repeat. I've got a number line. I wrap it around the circle, and I get units on the circle, on the circumference of the circle. So arc of 1 radian, arc of 1 unit makes 1 radian. So this is 1 radian. Arc of 2 units make 2 radians. Arc of 3 units make 3 radians. And arc of pi units makes pi radians. So this is pi radians. All right. Hope you're all following. All these things we have done yesterday, but we are quickly revising it so that we can move forward. All right. Pi radians corresponds to 180 degrees, students. School lo meeru em chadukunnaro, angle of a straight line is 180 degrees ani. So that's actually pi radians in real numbers, but that corresponds to 180 degrees. Right. Pi is a real number. Its value is 3.1415 approximately. We can add pi to real numbers like this. Let's say we can do pi plus 1 as 3.14 plus 1 gives 4.1415. Pi plus 5 gives you something 6.1415. Whereas I cannot add 180 degrees and 1. All right, 1 is a real number, but whereas 180 degrees system, I cannot add 180 degrees to 1. Hence, it is important that we understand angles in terms of real numbers, that is radians in physics. All right, so we are going to deal with radians. Of course, we'll have degrees as well. We will not forget degrees, but we are going to deal with radians in specific. All right. All right, let's see the conversion. 360 degrees corresponds to 2 pi. So 180 degrees corresponds to pi, that we have seen already. Yes, yes, it is an irrational number. That's okay, but it's a real number. So 180 degrees corresponds to pi. If I divide by 2 on both the sides, I get 90 degrees corresponding to pi by 2. Similarly, going further, 45 degrees corresponding to pi by 4, 60 degrees correspond to pi by 3, 30 degrees correspond to pi by 6, 15 degrees correspond to pi by 12. All right. So when we come across 60 degrees in physics, we usually mention it as pi by 3 instead of 60 degrees. Of course, in questions, you will also find 60 degrees, 30 degrees, and 90 degrees, 45 degrees, and so on. But when doing physics more specifically, we'll deal with angles in radians. All right, let's see what the trigonometric ratios are. You all know the ratios as you have learned in standard 10th, 9th and 10th. Let's see. Let's quickly see what you've learned. So we've got opposite side, adjacent side, and hypotenuse. So ratio of opposite to the length of the hypotenuse is sine, defined as sine theta. So cos x. Now the other angle is x over there, x as mentioned, x over here. Cos x over here is equal to 3 by 5. All right, and which is equal to sine theta. All these things you have learned in 10th, but don't worry, we will have a new approach today, a new way of looking at all these things again, which is very important for physics of +2 level. So here x plus theta is 90. So x is equal to 90 minus theta. So I get cos of 90 minus theta is sine theta. That's how I proved cos of 90 degrees minus theta is sine theta. Or in radians, if I say cos of 5 by 2 minus theta is sine theta. That's how I've proved here. Similarly, we can also prove sine of 90 minus theta is cos theta. All right. Now, students, we have got these cos of 90 minus theta as sine theta, sine of 90 minus theta as cos theta, tan of 90 minus theta as cot theta, and so on. From the triangle we have considered. All right, we have considered a right angle triangle, and from there we have derived all these things. We have concluded all these relations from the triangle. But today we'll have a look at all these things, fresh, with a fresh mindset. We're going to deal with circular functions. Like trigonometric functions are also called circular functions. They are actually called circular functions. Trigonometric functions are basically called circular functions because they all can be derived from a circle. From a unit circle given, I can derive all the ratios, all the relations, whole of dam of trigonometry can be derived right from the circle, unit circle. So let us have a fresh look at this from this point of view. What's the point of view? That we are going to deal with circular functions and derive all these ratios, all these relations from circular functions. All right. All right. So let's get started. Right. Hope you're able to see the board. If that is shining a bit, I'll just switch off the light. Hope everything is clear. All right, as I told you, we'll start with circle again, unit circle. All right. Students, if at all you have got doubts, let's invest time for doubts at the last 5 to 10 minutes at the end of the session. All right. And so that you completely focus on the class right now. Any doubts you have got, you jot it down, and then you can ask me at the last and at the end of the session. All right. Okay. Understand one thing, students. And let's understand what is projection. I've got a line, I've got a straight line or a plane, I've got a plane, I've got a rod or some object of some length. When I say find the projection of this one on this line or a plane on this line, what I do is I shine light in this direction. What direction? In the direction perpendicular to the plane. I shine light in the direction perpendicular to the plane. So what I get, this is called the projection of this rod or length on this line. So whenever I say projection, it's a shadow. Shadow due to the light shining perpendicular to the line on which you require the shadow or on which you require the component. So this is called the component or the shadow. All right. Now, so I hope this is clear. I repeat, I have a line, I have a rod of length, some length. I want the shadow of this one on this one or the component of this on this one. So what I do, I shine light from here. I get a perpendicular. This length P is called the shadow or the component of this rod on this line. So whenever I say component, think of that in terms of shadow. So whenever I say utter a word component, that means I shine light perpendicular to the line, I get a shadow, that is nothing but the component. All right, component is nothing but the shadow of the required object. or the given object, sorry. All right. Now that you have understood what I mean by shadow, let's define cos and sine. I've got a circle, unit circle again, on which the number line is wrapped already, as you have seen. So I've got a unit radius this way. And this is angle, let's say alpha. Okay, instead of theta, I'm taking it as alpha. Just for convenience. I mean, it's just the name of the angle. So I take it as alpha. The component of this one on this line, x-axis, let's say I call it x-axis or horizontal axis, and vertical axis, y-axis. You can name it as x and y, x dash, y dash, x1, x2, anything, just the names. So the component of this radius on this one, how do I get it? I shine light from this direction, along this direction. So I get a shadow like this. I get a shadow like this, and this is defined as cos of alpha. So what is cos now? Shadow or the component of the radius along the line from which alpha is measured. Alpha is measured from here. So this is called cos alpha. Shadow of this radius on the line perpendicular to this vertical line, along the vertical line, is sine alpha. So this is cos alpha. This is sine alpha. So how do we define sine now? The shadow of the radius along the vertical, shadow of the radius along the horizontal. Along the horizontal, it's cos. Along the vertical, it's sine. Again, it is cos on the line from which the alpha is measured. Alpha ikkada nunchi measure chestunnamo. So this is cos alpha. Whereas perpendicular to this line is this one. This is sine alpha. Shadow on the vertical line is sine alpha. Shadow on the horizontal line is cos alpha. Let us say, just for instance, idi nen theta anukundam anukundi. So what does this become? This becomes cos theta, and this becomes sine theta. Why? Because angle is measured from this line. Shadow on the line from which the angle is measured is cos. Shadow of the line on which is perpendicular to the initial line, first line. Shadow on the line from which the angle is measured is cos alpha. Shadow on a line perpendicular to this line is sine alpha. All right. All right. Now let's quickly visualize and see what is happening as I move around. As I go on increasing the alpha, let's see what is happening to sine and cos. If alpha is this much, alpha is 0, what is my cos alpha? My shadow is complete unit, this is length 1, unit radius. So this, my shadow is also unit radius. So my cos alpha is 1. So when alpha is 0, cos alpha is 1. So cos 0 is 1. This we already know from triangles, but we are going to take a fresh look from the perspective of circular functions. All right. So we're going to derive all that you know from the perspective of circular functions. All right. I hope this is clear till now. So sine of when alpha is 0, my cos 0 is, my shadow is the radius vector itself. So cos 0 is 1. Now let's forget sine for some time. When this radius vector becomes vertical, that means my alpha is 90 or pi by 2, 90 degrees, which corresponds to pi by 2. But let's deal with pi by 2 radians itself. So pi by 2. So what is my cos now? What is the shadow? Can you quickly tell me what the shadow is in the chat box? Quick. What is the shadow of the vertical line on the horizontal line? Students, what is the shadow of this vertical radius on this horizontal line. 0, 1. Good. Good, Bhaveshri. I want quick answers. See, we are very less in number. We can interact a lot. Okay. All right. Students, see, initially we'll go slow because these are fundamentals. These have to be strong. So we'll go a little slow. That's okay. We'll take care of everything. You don't have to worry about whether we are going slow or fast. The ultimate idea is that you should understand everything and should be able to crack exam confidently, for which the fundamentals are important. All right. So please interact. That's okay. If at all we want to slow down initially for the first 1 or 2 days, that's okay. All right. Now let me tell you how the shadow is 1. First of all, you'll understand why it is 1. This is my radius vector. This is my radius. When the alpha is 0, I shine light in this direction. So దీని షాడో ఏముంటుంది? ఈ నా మార్కర్ షాడో ఏముంటుంది? Itself కదా? Length of the shadow is equal to itself kada. So that is why length of the shadow is 1. Is it clear? Is it clear why length of the shadow? That's a good doubt. Is it clear why the length of the shadow is 1? All right. Okay. See, length of the shadow is 1 because as I rotate this one, when this becomes horizontal, the shadow will be equal to the shadow ఉంటుంది కదా, and the shadow is equal to the length of the marker. What is the length of the marker? 1 unit. So shadow is also 1 unit. So I hope it's clear now to everyone. See, a couple of students are responding, but I want everyone to respond. I want this to be clear to everyone. Students, things will be little difficult, I'm telling you, in physics. Things are little challenging, but very interesting. You'll have to stretch your brain a bit. All right. All right, Bhavishri, good. Bhavana, is it clear to you why the shadow is 1? All right, Bhavana, is it clear to you why the shadow is 1? See, I'm very particular about every student. That's okay, we can go slow for a couple of days. But these things have to be clear because as we go forward, we'll be applying these things a lot. All right. All right, good. Great. Great. Thank you. Thank you, Bhavana. That's good. I really appreciate the ones who are asking doubts. I really appreciate. Very good. See, squeeze out knowledge from us. All right. As a teacher, you squeeze out knowledge from us. You take everything possible. We are ready to give everything possible to you. Let's get back to this one. So we got cos 0 as 1. All right. Cos 0 degrees or 0 radians as 1. As this rotated, it became pi by 2. So this radius has now become vertical. The shadow of the vertical is nothing but a dot. Shadow of the vertical is nothing but a dot. So that is why cos of pi by 2 equal to 0 because length of the shadow is 0. All right. Now let's see what happens if I rotate further. As I rotate further, when this angle is more than pi by 2, my cos of angle which is greater than pi by 2 is negative now. Why is it negative? The shadow is on the left side. Right side of x-axis is positive, left side of x-axis is negative. Shadow is on the left side, so it's negative. When I further rotate this, when the angle becomes pi, when the angle becomes pi, when this radius becomes horizontal, directed towards left, what is the shadow now? It was 1 when it was directed towards right. So length of the radius is 1. So shadow will also in magnitude be 1, but as a number it would be -1. So cos of pi is equal to -1. All right. Now I further rotate. When I further rotate this angle, my cos is again negative. Cos was positive here. As I rotated, the moment I utter cos, think of the shadow on the horizontal line. The moment I utter cos, think of it as a shadow on the horizontal line. What is the cos of this angle? This shadow is the cos of the angle. What is cos of pi by 2? Shadow, which is 0. What is cos of pi? This shadow, which is -1. What is cos of? How much is this angle, students? It is pi by 2 plus pi by 2 plus pi by 2. 3 pi by 2. So when the radius turns to 3 pi by 2, shadow is again a dot, 0. So cos of 3 pi by 2 is again 0. Cos of 3 pi by 2 is again 0. When the angle now becomes 2 pi, pi by 2 plus pi by 2 plus 3 pi by 2, pi by 2 plus pi by 2. So total is 3 pi, 2 pi. When the angle now becomes 2 pi, what is the shadow now again? Shadow is again 1. Right? Shadow is again 1. So cos of 2 pi is 1. Now if I further rotate, when it angle is greater than 2 pi, 4 pi, 4 pi, 5 pi, 6 pi, 5, 7 pi, 8 pi, 9 pi, so on, my values are going on repeating. As this my radius is going on a circle, my shadows are going on repeating. As this goes on rotating, my shadows on the x-axis are going on repeating. That means they are periodic. That means because circle is periodic, my functions derived from this are also periodic. So circular functions, trigonometric functions are periodic. But what is the specialty of this periodic function? They have a period of 2 pi, because after every angle of 2 pi, whole of the scenario is same. Let's say my vector was here, my radius is here. After it rotates by 2 pi, comes back to the same position, whole of the scenario is same. When it was at this angle alpha, it rotated through an angle of 2 pi, it came back to alpha again. So this is again, scenario is same, exactly the same. So whatever constants we derived for alpha, when the angle was alpha, it is same when alpha is angle is alpha plus 2 pi. So my whole scenario, whole snapshot is same for every 2 pi. So the period is 2 pi. So the functions are periodic with a period of 2 pi. So all trigonometric functions are periodic. Basic trigonometric functions are periodic with a period of 2 pi, because circle is periodic with a period of 2 pi. Because they are derived from this circle, unit circle, all of them are periodic with a period of 2 pi. Students, I would like to tell you something now at this point of time. You have a notebook here. This is your page. Hope you're writing down something on your notes. When I give you a gap, please make a note of it. Okay. Bhavna, it's a very good doubt. Uh, Bhaveshri wants to unmute for a minute, for a second. Yeah, please, Bhaveshri, you can unmute.
Yes, Bhavyashri, you have given permission.
Yes, Bhaveshri. Please unmute and speak and make it quick.
Yes, students, permission is given. You can unmute yourself and ask the doubts.
All right, Bhaveshri, I'm waiting for you to ask a doubt. All right. May I continue?
Sir, one student wants to explain the topic once again.
The whole topic?
No, no, sir. This
Okay.
last hypothesis and adjacent what you have said.
Okay.
Yes, sir. That as one student want to explain once again.
Okay. I don't know what you are hypothetically talking. All right. All right. I'll just quickly repeat whatever I said at the end.
Sir,
Yes.
as we take unit area 1, we got a sine alpha 1 as అక్కడ 90 degrees ఉంటది కదా సార్ π/2 అన్నప్పుడు cos 90 జీరో యాంగిల్ కదా సార్.
Perfect. Very good. Very good. I think you missed one point. I'll just tell you. చూడండి నేను ఇక్కడ మళ్ళీ డ్రా చేస్తున్నాను ఇది. I got your point. Is it Bhavyashree? Who is it?
ఎస్ సార్ భవ్యశ్రీ సార్.
Yeah. Hi, Bhavyashree.
హాయ్ సార్.
Yeah. ఇది π/2. All right. నా రేడియస్ ఇలా వచ్చింది ఇప్పుడు వర్టికల్ వచ్చింది. నా రేడియస్ వర్టికల్ ఉంది అదే కదా మీ డౌట్. నా రేడియస్ వర్టికల్ వచ్చినప్పుడు వాట్ ఇస్ ద షాడో ఆఫ్ దిస్ ఆన్ ది ఎక్స్ యాక్సిస్? లైట్ ఇస్ షైనింగ్ లైక్ దిస్. What is the shadow now? Shadow of this rod on the x-axis?
కాస్ ఆల్ఫా.
Cos alpha, right? Cos π/2. Very good.
సార్.
ఇప్పుడు షాడో ఎంత ఉంటుంది? డాట్ లాగా ఉంటుంది కదా. సన్ రేస్ వస్తున్నాయి. ఇఫ్ ఐ హావ్ ఎ వర్టికల్ స్టిక్, నేను వర్టికల్ గా పట్టుకుంటే నా షాడో ఎలా ఉంటుంది? ఒక డాట్ లాగా ఉంటుంది కదా.
ఎస్ సార్.
అయితే షాడో ఏమైంది? జీరో అయిపోయింది కదా.
ఎస్ సార్.
ఇప్పుడు ఇదే రేడియస్ వెక్టర్ ఇక్కడ ఉండే అనుకోండి, సమ్ యాంగిల్ ఆల్ఫా. ఇప్పుడు షాడో ఎంత ఉంది? ఇంత ఉంది. ఇంత ఉంది షాడో, రైట్?
Sir,
Alright,
okay,
okay.
sir.
You understood the point now? As this went on increasing, shadow went on decreasing. When it became vertical, shadow became zero. When angle is becoming obtuse, my shadow is becoming negative.
Yes, sir. Now I understood that doesn't depend on the angle.
Exactly. That depends on the angle. నేను యాంగిల్ రాడ్ ని రొటేట్ చేస్తూనే ఉన్నాను, రేడియస్ ని. నా షాడో చూస్తూనే ఉన్నాను. నేను షాడోని అబ్జర్వ్ చేస్తున్నాను. నేను షాడోని విజువలైజ్ చేస్తున్నాను. ఆల్రైట్. సో దీస్ ఆర్ ద వాల్యూస్ వి గాట్ ఇట్ ఫ్రమ్ షాడో. వాల్యూ ఆఫ్ ద షాడోస్, లెంత్ ఆఫ్ ద షాడోస్. cos 0 ఉన్నప్పుడు ఎంత వచ్చింది? లెంత్ 1. కన్విన్స్డ్. cos π/2 ఉన్నప్పుడు లెంత్ ఎంత వచ్చింది? 0 వచ్చింది, బికాస్ ఇట్ వాస్ ఎ డాట్. cos π ఉన్నప్పుడు లెంత్ ఎంత వస్తుంది? -1 వస్తుంది. దిస్ మై షాడో. cos 3π/2 ఉన్నప్పుడు ఏమవుతుంది? మై రేడియస్ ఇస్ వర్టికలీ డౌన్వర్డ్. షాడో అగైన్ బికమ్స్ ఎ డాట్. cos 2π ఉన్నప్పుడు my radius is towards right, my shadow is also towards right, which is of same length, 1.
Yes, sir, I understood now. When the shadow is vertical, it becomes a point size and it will be 0. And when in x-axis, when it is positive, we have to take positive. When it is negative, we have to take negative value.
Excellent, excellent. Excellent. That's absolutely right, Bhavyashree. All right, so I'll continue further. So doubts are clear, right?
Yes, sir. Cleared, sir.
Okay. Yeah, Bhavana will have doubt sessions, so don't worry about it. You will listen to the recorded session. Mari doubt session kuda untundi. Doubt session lo malli doubts adugochu meeru. All right, so don't worry about if at all you are missing some minute things, don't worry. I'll make sure that you understand everything. All right? That is okay if we go slow for a couple of days. Absolutely okay. All right. Now, student, I want to tell you something how to make a note of certain things. This is your notebook page. ఇక్కడ మీరు ఏదైనా రాసుకుంటున్నారు అనుకోండి, ఈ సర్కిల్ రాసుకున్నారు, రేడియస్ వెక్టర్ రాసుకున్నారు, కాస్ యాంగిల్ రాసుకున్నారు, cos 0 అని రాసుకున్నారు. ఇఫ్ ఐ అటర్ ఎ న్యూ టర్మ్, write a footnote here. ఒక లైన్ వేసుకోండి ఇక్కడ కింద, or on the right hand side, wherever you're comfortable with. So this, if footnote లో any term if I introduce, you please write it down over there, so that when I teach you the term, you'll have to come back to this and relate to this one. నేను దీనికి రిలేట్ చేయడానికి టర్మ్ చెప్తాను, కానీ ఆ టర్మ్ చెప్పినప్పుడు అది అర్థమైనప్పుడు యూ హ్యావ్ టు కమ్ బ్యాక్ టు దిస్ అండ్ రిలేట్ టు దిస్ పేజ్. ఆల్రైట్, I hope you got it. You write something in notes, something related to this I will utter, you note it down here. When I teach this to you, when you understand that particular point, you come back to this and relate to this page. Alright, so that cross going back and forth is very important. ముంగట వెళ్తాము, 2 steps will go forward, 1 step will come backward, again you go 2 steps forward, 3 steps forward, come 1 step backward. All right, that way. So make note of things, certain things like that. So what I mean to say right now is, circular functions are periodic functions with period of 2 pi. Enduku? Because circle is periodic of period 2 pi. Ade naku inkoka curve undanukondi, hyperbola. You don't know what hyperbola is. So write down hyperbolic functions here. ఈ స్పేస్ లో హైపర్బోలిక్ ఫంక్షన్స్ అని రాసుకోండి. హైపర్బోలిక్ ఫంక్షన్స్ అని రాసుకోండి. Alright, when I teach you hyperbolic functions, you come back and relate to this. When I teach you that, you'll be able to relate this and that. So it's very important that you write a marker, hyperlink laga, a chinna reminder laga. So write down hyperbolic functions in this footnote. Alright, let's go forward. All right, for next 1 minute, we'll do an exercise. I've got a radius like this, some angle alpha naught. You will have to tell me, as I go on telling the values of alpha, you will have to tell me whether the cos is positive or not, or negative, positive, 0 or negative. All right, you should quickly type in the chat box, positive, negative or 0. Only these 3 options. All right. When alpha is between 0 and pi by 2, when alpha is between 0 and pi by 2, what is cos? Is it positive or negative? Or 0? Fantastic. I got an answer. Good. Rakshit, Gayatri. Gayatri gave me the first answer. Good. Avestri, good. How about others? There are many students here. See, we want everyone to interact. See, why am I asking you to interact now is so that I get to know what I'm speaking is you're able to understand or not. If you don't answer, how will I get to know whether you are understanding or not? It's just a minute exercise, 1 minute. Great. Fatima, give an answer positive. All right, I'll give a chance to others as well. When alpha is between pi by 2 and pi, when alpha is between pi by 2 and pi, what is cos? Positive or negative? Positive or negative? Great. Fantastic answers. Great. All right. When it is between pi and 3 pi by 2. When it is between pi and 3 pi by 2. What is cos? Positive or negative? Fantastic. One of you gave a wrong answer. It's not positive, student. Student. Now projection projection towards left vastundi. Shadow towards left vastundi. Projection is nothing but the shadow. I will talk of the shadow till your second year. Till you enter into engineering, I'll talk of the shadow only. Yes, good. One of you got it wrong. Please correct yourself. Yeah, good. Yeah, you're right. All right, now what happens? Another 30 seconds. What happens when it is between 3 pi by 2 and pi, 2 pi? Between 3 pi by 2 and 2 pi. All right, positive. Fantastic. What is cos 0? Don't tell me from memory that you cos 0 is 1. Tell me from visualization that what kind of shadow do you see? Cos 0. Fantastic. Cos pi. Cos pi. Cos pi. Pi. Not pi by 2. Pi. Here. Cos pi, students. Cos pi. Cos pi లో ఏమవుతుంది? This is pi. My radius, now my radius is over here. So what is the shadow of this one? -1. Correct, Bhavishri. That's absolutely right. Bhavana, absolutely right. Gayatri, absolutely right. Jyoti is right. Fatima, absolutely right. Very good. Everyone is absolutely right. Excellent. All right. Now when it is pi by 2, alpha is pi by 2. Quick. 10 more seconds. Great. 3 pi by 2. 3 pi by 2 is over here. All right. Perfect. So I'll go forward. Acha, have you written this hyperbolic functions in the footnote? Type yes in the chat box. Hyperbolic functions and Raskunara. All right. Fantastic. All right. Now let us see. This is alpha. This is minus alpha. Makes sense, no? I told you yesterday. Clockwise is positive, anti-clockwise is negative. Sorry, anti-clockwise is positive, clockwise is negative. Why? Because the tangent line was pasted here. If it were to be pasted here while deriving all these things, our whole of the trigonometry would have been reversed. I mean, convention would have been reversed. Math would have been same, but convention would have been reversed. But because I pasted the number line here, my anti-clockwise is positive, clockwise is negative. This question was asked in an interview for an MBA student in IIM. IIM Bangalore CAT exam రాసిన తర్వాత this question was asked. Why do you take anti-clockwise as positive and clockwise as negative? All right. So things are very important. All right. Now look at this. What is the cos of alpha? What is cos of alpha? Positive. Right? What is cos of minus alpha from this diagram? Positive or negative? Cos of minus alpha from this diagram. From this circular diagram. Positive or negative? Cos of minus alpha. Look at this. What is cos alpha? Projection along the x-axis. This is cos alpha and that is cos minus alpha. Positive, excellent. That's absolutely right, excellent. Positive is absolutely right, students. Yeah, Bhaveshri, what happens is if I keep the tangent over here, my clockwise, I paste this, I wrap it around circle. So clockwise angle becomes positive and anti-clockwise angles become negative. But what I did, I pasted this tangent line over here. So angle anti-clockwise became positive, clockwise became negative. That's the only difference. This is a convention matters. All right. Anyway, that's fine. Now look at this. From the diagram, I can write cos of alpha is equal to cos of minus alpha is equal to cos of alpha. So this is one expression which I can equation which I can derive from the diagram from the circular function. You can take it, Bhavana. You can take it. Nothing wrong. All right. You can do whole of math with a different reverse convention. You can do it. I have done it with the pasting it left side also. Nothing wrong. All right. Now let's look at further. Right. Let's look further. Now this I have shown why cos of minus alpha is cos alpha. Now what I do? Cos of alpha plus pi. So pi plus alpha. So what is cos of alpha, pi plus alpha now? Tell me what is the shadow? Is negative or positive? Negative, right? Good. Negative. And when it's negative, you have to notice that this is equal to this. this length is equal to this length, right? From these two triangles, they are congruent triangles. This angle is alpha. From these two triangles, they are congruent. This base is same. This length is equal to this length, but negative. Shadow is length is same, but it's on the left side, so it's negative. So I can write cos of pi plus alpha is equal to minus cos alpha. Is it clear? Is this equation clear? All right. Now let's go further. Now let's see how do we deal with sine. Now what is sine? I defined sine as a shadow on the vertical axis. So if I've got a radius like this, and this is alpha, this is my sine. Now tell me, what is when alpha is 0? What is sine value of sine? Sine 0? Not from memory, from circle. I know you all know what is sine 0, but from the circle, what do you see? When alpha is 0, what is sine 0? Fantastic. Rapid fire answers, huh? All right. One of you gave a wrong answer. See, alpha is 0 అంటే ఇలా ఉంది. నా రేడియస్ ఇలా ఉంది. దీని షాడో ఎలా వస్తుంది? షాడో ఇటు సైడ్ నుంచి లైట్ షైన్ చేస్తున్నాను. ఇటు సైడ్ నుంచి లైట్ షైన్ చేస్తే ఈ షాడో వస్తుంది నాకు, వర్టికల్ షాడో. Shadow on the vertical is sine. Shadow on the horizontal is cos. Shadow on the vertical, when the alpha is 0, it becomes 0. It becomes a dot. When the radius is like this, it becomes a dot. Gayatri, is it okay? I'm not saying cos. Gayatri, you got confused. Cos of 0 is shadow on the x-axis. Yeah, good. So shadow on the vertical axis is 0. So sine 0 is 0. 0. When this alpha becomes pi by 2, now what is the shadow on the vertical line of the radius? Excellent. Excellent. Uh-huh. Think again, think again. One of you have given a wrong answer. It's not 0. Shadow of this rod, when it becomes vertical, shadow on the vertical line itself. Iski shadow, vertical line per. Light is shining from this side. So shadow on the vertical line is 1. Right. Good. So it's not 0, it's 1. Now so sine pi by 2 is, see, let's say after 1 year, you forget whole of trigonometry. You just draw this circle and just logically go on doing things. Whole of trigonometry will appear in front of you. Trigonometry enough for us to crack physics problems. I'm not talking about trigonometric equations. I'm talking about trigonometry enough for us to crack physics problems, enough from this diagram and graphs. All right, sine pi by 2 is 1. When this angle becomes pi, what is the shadow? The angle is pi. Excellent. I got answers, but I want everyone to answer. Sine. I'm talking about sine pi. Sine pi. Sine pi ante I will take shadow on the vertical line, not on the horizontal line. Cos pi is minus 1. All right, cos pi is minus 1. But sine pi, yes, 0. Right. Sine pi is minus 1. Sorry, cos pi is minus 1. Why is it minus 1? Because shadow on the horizontal line is negative 1, but shadow on the vertical line of this rod is 0. So sine pi is 0, whereas cos pi is minus 1. I hope this is clear to you all. So sine pi minus 1. Similarly, sine 3 pi by 2. Sorry, sine pi is 0. Sorry. Sine pi is 0. Sine 3 pi by 2 is minus 1. And again, sine 2 pi is 0 again. All right. Things are clear. Yeah, I got the answers, but I am unable to read all the names. So, but I just hope everyone is responding. All right, good. All right, now let's prove other equations now. I've proved sine pi plus alpha is minus cos alpha. So I've got alpha here. Look at this. If this is alpha, this is pi minus alpha. This whole angle is why? If this is alpha, this is also alpha. This whole is pi. So this will be pi minus alpha. Right? Now look at this one. Cos of alpha is this much. The moment I say cos, shadow on the x-axis. The moment I say sine, shadow on y-axis. Cos and sine are shadows. Nothing more than that for us in physics. All right. Now, this shadow is this way, and its shadow is ila undi. Now, this shadow is negative of this one, right? Same in size, same in length, but oppositely directed. So I'll write cos of pi minus alpha is equal to cos alpha. Is that clear? Is this clear? Is this equation clear, students? Type yes in the chat box. Okay. Okay. Others? Gayatri, yes. Bhavishri, yes. All right. Look at this. I'll explain it again. Ashita, look at this. Listen to this carefully. That's why I told you. Couple of days, let's go slow. That's okay. But once you get the thought process, we can rush forward. Let's inch forward right now. That's okay. This equation I don't know. Now this cos of alpha is this much. This is cos of alpha. And this is cos of 90 minus alpha. This one. Why? Because my radius is this way. When the radius is this way, this is cos alpha. When radius is this way, this is cos of pi minus alpha or 180 degrees minus alpha. If you see, these two triangles are congruent. This is alpha, this is alpha. This is hypotenuse is 1 and 1. So, and this is length is same, this length is same. So these two are congruent triangles. From that, I can say that this length is equal to this length. But this is on the negative side of the x-axis. So cos of pi minus alpha is equal to minus cos alpha. Okay. Is it clear now? Or is it still blurred? Yeah, I think it's better now. All right, good, Ashita, you have understood. Good. All right. So is it clear? Madam, is it clear? Is my screen clear?
Somewhat blur, sir.
Oh, it's blurred.
Yes, sir.
Perhaps a network issue, ma'am.
Now, focus, we are getting a light focus there.
Right. All right. I'll write a bit bigger. That will help. But is it still blurred?
Now it's fine, sir.
All right. Thank you, ma'am. Yeah. And I've written a little bigger, so I think that will help. All right. Now, let us say sine. And what alpha? This is unit and this is alpha. So sine alpha would be this one, this shadow. All right. And now, if this is minus alpha, my sine is now this much. In both the cases, length is same, but oppositely directed. So I can write sine of minus alpha is equal to minus sine alpha. Whereas cos of minus alpha is cos alpha, sine of minus alpha is minus sine alpha. Why? Because shadow of this one on the vertical line is sine, on the horizontal line is cos. Both the cos components are same, but whereas sine components are same in length but oppositely directed. All right. Now let's see what is pi plus alpha. All right. So what is sine of pi plus alpha? This is sine of pi plus alpha, this lower length. Again, minus sine alpha. Let's see what is sine of pi plus alpha. What is sine of pi plus alpha, students? Can you all try? Sorry, sine of minus alpha. If this is alpha, this is pi minus alpha. Now tell me whether it's equal to sine alpha or minus sine alpha. Quick, this is the last question we'll do. We'll have to move on to chemistry as well. Okay, there seems to be. All right, is this size better? Like I'm writing bigger in size, so I think this will help a bit. It's blurred. All right, students will continue tomorrow. You think of this? Excellent. Fatima has given me the answer. Excellent. I'll not reveal the answer now. Gayatri also has given the answer. Good. Excellent. Brilliant. I highly appreciate both of you. I hope others are also getting the answer, but I suggest you tell me the answer tomorrow. All right. The question is sine of pi minus alpha. I've shown you pi minus alpha angle as well. You have to just think in terms of shadow and tell me whether it's plus sine alpha or minus sine alpha. All right. Students, with this, we conclude today's physics session of basic mathematics. All right, I'm getting the answers. Good, excellent. All right. All right, students, have patience. That's okay. I got that you all got to know the answer, but except one answer is wrong. Think again, or I'll tell you the answer. It's plus sign alpha, but just think how it is plus sign alpha. All right, plus is all right, negative is wrong. All right. Thank you so much, students, for joining today, and please be on time tomorrow. Do not miss the classes. Initially, it's very fundamentals are very important. Do not miss any class, because once we get into the subject, deep into the subject, we cannot wait for anyone. All right, we will have to go faster so that the ones who come along with us, we will be able to crack problems, and others will be left behind. All right. Thank you, ma'am. Chandrika, ma'am. Over to you, ma'am.
Yes, sir. Thank you, sir. Yes, students, now you have a continuation of chemistry. Before that, who is the student logged into with Zoom user? Name Zoom user. Please put your name in the chat box. Zoom user. I want to know your name. Please put it in the chat box. Now we will continue with chemistry. Prachi ma'am, you can continue the session now. Yes, Prachi ma'am, you can continue the session, ma'am. Yes, ma'am, now you can unmute. You got the permission, now you can unmute, ma'am.
Hello, everyone, and welcome to this session. So now in this session, we will start with chemistry. So I hope you all are excited to start with chemistry. Also, I'll be sharing my screen. So just put a thumbs up if you are able to see my screen, and also if you are able to see my video and you are able to hear me. Yes. Yes. So I hope everyone is there. So just give a thumbs up. And can you see my screen?
Yes, ma'am, it is visible.
Okay, ma'am. Yes. So yes, students, first thing that I want you to do is you have to rate chemistry based on what is your understanding about the subject and likability. So you have to rate it between 0 to 10 so that I'll get an idea like what's are the things that you understand, you don't understand, or whether you like the subject or you find it difficult. So just quickly do that and then we will see. So basically today we will be starting with some basic concepts of chemistry. And before that, we have to understand why it is so important to learn about chemistry and where around us exactly this subject is useful. So we have to relate this subject to the things that are happening around us so that you get a better understanding of the things which are, so you would know that how whatever you are learning in your textbook, how it is related to the outside world. So yes, it is very important to know why are we learning this subject, which is chemistry. So yes, okay. Bhavna, it says, okay, 10. So she likes the subject. And Leela, it says 9.9. And I want others also to rate it. And the first thing that you have to remember in my class is that the involvement is very important. You have to be involved in the sessions. You have to keep asking the questions whether when you are not able to understand the particular topic. And the last thing is to revise the content again and again. So memorize and revise and ask lots and lots of questions. And also try to be active in the sessions. So yes, what do you think? Are you all chemists or not? So yes, indirectly you can say that we all are chemists because lot of chemistry is happening in us also. For example, right now if we are reading this text, there also the chemistry is happening. What is that chemistry? So when you are reading this text, then the chemical that is retinal in your eyes, it is converting the visible light to the impulse signals. So there the chemistry is happening. It is constantly happening with us when we are looking at something. It is happening when we are doing the respiration. It is also happening when you're eating the food every day. That is the digestion of food. And if I say, where is chemistry around us? So my answer would be, it's everywhere around me. Be it the clothes I am wearing, be it the clothes we are wearing, the medicines we are eating, the things we are using, ranging from the pen you are using, the buckets, the bottles, the paint on the walls, everywhere there is lots and lots of chemistry that is happening. And with the help of this branch of science, we will understand the phenomena and the things that is happening in our body and around us. So I hope now you know, now you understand how important is this subject to understand the things around us. So yes, now it's very important how exactly are we going to learn this subject. So basically, if we say, if we look at chemistry, then there are different branches of chemistry. But here we will just see the branches, or we will categorize the subject that is useful for us. So the first branch of chemistry that we will be seeing is inorganic chemistry. That is inorganic chemistry. Then we have organic chemistry. After that, we have physical chemistry. And the other one is analytical chemistry. So now the next question that you might be having is, why are we categorizing this subject? So the answer is so that the study of the whole subject becomes easy, and the categorization of things makes it easy for us to grasp the subject. So now let's see what are we going to learn in the inorganic chemistry. So here basically this is the introductory session so that you have the idea what this subject is all about and how are we going to proceed in the further sessions and how the subject is divided. Because once you know how the chemistry is divided, over the period of time, you will know which part is strong. So sometimes some of the students, they are strong in physical chemistry, some of them are strong in inorganic chemistry. So by the time you will know which is the topic in which you have the strong hold. So let's see what is inorganic chemistry. So the inorganic chemistry is about the compounds that are not having carbon. So when the studies were started, so initially people, they have divided chemistry into just two branches, which is organic chemistry and inorganic chemistry. And this division was just based on simple observation. That is, They have categorized organic compounds as those compounds which you are getting from living things. For example, from animals, from plants. And then whatever you are getting from minerals and rocks, those compounds, they were categorized as inorganic compounds. And from there, we have got the two branches, which is the inorganic chemistry and organic chemistry. So now in organic chemistry, we will be learning about the compounds that are having carbon and hydrogen. And along with that, we will see the carbon compounds which may have oxygen, nitrogen, or some of the halogens. So halogen in general will be denoted by X, which includes bromine, chlorine, fluorine, and iodine. And we will be learning about these things in details as we move further. So organic chemistry is the chemistry of compounds which are having carbon and hydrogen. And the other thing that you should know, that there are so many compounds around us in nature that is having carbon. So a separate branch was dedicated to the compounds which were having carbon and hydrogen. Now, leaving the compounds which are having carbon and hydrogen, we are left with other compounds which we are getting from rocks or minerals. So all of those things will be studied in the inorganic chemistry. So this will be including the compounds that don't have carbon. Now, here is the physical chemistry. So in physical chemistry, we will be learning about the behavior of these compounds, that is the inorganic and the organic compounds. So here we will be learning about the behavior of materials. And the fourth one is analytical chemistry, which I think might be new to you, right? For some of the students, they might be hearing this word for the first time. So yes, so someone, Bhavna asked me, what is inorganic chemistry? So inorganic chemistry is the chemistry which includes the study of the compounds apart from the organic compounds. Now, what are organic compounds? So organic compounds are the compounds which are having carbon and hydrogen. For example, let's suppose we have glucose, we have methane, and various other compounds, like you are using the fuel in the vehicles, right? So that is octane. So those compounds, they are having carbon and hydrogens. Now, excluding these compounds, whatever compounds, for example, if we are learning about HCl, if we are learning about H2SO4, or if we are learning about the salts, or let's suppose all the elements which are present in the periodic table. For example, I'll show you the periodic table. So this is the table that we will be seeing a lot in chemistry, right? So in inorganic chemistry, I'll see how these all compounds, they are existing in nature and what are their properties. Starting from this is S block. I'll also learn about the P block. I learn about the F block. I learn about the D block. And these all things I'll tell you slowly by slowly, right? In steps, in small steps, we'll see what are the things that we will be learning about. And then we have the analytical chemistry. So analytical. So this word comes from, this means analysis. So this is basically all the part of the chemistry which includes the practical chemistry. It is the chemistry in which we will be analyzing the compounds, whether they are organic compounds or the inorganic compounds. So I hope now you know what are the branches of chemistry that we will be learning about. Now quickly let's see the chapter that constitutes the inorganic chemistry. So here we will be learning about S block elements. We will be learning about P block elements. We will be learning about F, D and F block elements. And then we will be learning about the coordination chemistry. And then we will be learning about coordination chemistry. So these are the chapters that we will see in the inorganic chemistry along with hydrogen. And the first chapter that we will see is the classification of elements. Classification of elements and periodicity. So these are the chapters that we will be seeing in the inorganic chemistry. Now, what are the chapters that we will be learning in the organic chemistry? So here some of you are asking the questions. So what we will do is we will take those questions at the end of the session so that the continuity of the session is maintained, right? So yes, of course, I'll answer all the questions. But first, let's see what are the chapters that are included there. And then we'll learn few things in the detail. And then I'll take the general questions. I hope that is okay with you. So now in organic chemistry, we will be learning about the general organic chemistry. We will be learning about general organic chemistry, which basically includes classifying and the purification of the compounds. Then we will learn about hydrocarbons. And then it includes the organic compounds containing what atoms? It may be oxygen, it may be halogens, or it may be nitrogen. And then you have the last chapter, which is biochemistry. And then we have biochemistry, and the other chapters includes polymers and like that. Chemistry in everyday life, which we also be learning in the organic chemistry. Now, there are few units which you will learn in 11th standard, and there are the other units which you will be learning in your 12th standard. So that also I'll tell you what are the chapters that we will be covering in your 11th standard. Now, in physical chemistry, so in physical chemistry, we will learn about how these substances are behaving, right? For example, let's suppose if I take water and I heat it. So what I'll see that water has converted to vapors. So now I am going from solid to, I am going from liquid to vapors. Similarly, if I take liquid water and I decrease the temperature, so what I am going to get? I am going to get ice. So all of these things we will be learning in the physical chemistry, right? Like what is happening if we are changing the temperature, pressure, or volume. So how the properties are changing, how the material is behaving with the changing conditions. So in this, we will be learning basics about the how the matter look like. Basically, we will be learning about the structure of atom. And also, we will be learning about how these atoms, they are forming the bonds between themselves. So we will be learning about chemical bonding. We will be learning about chemical bonding and molecular structure. We will be learning about chemical bonding and molecular structure. And the other units that you will be seeing here is we will be learning about thermodynamics. Then we will learn about equilibrium, which will include both chemical and ionic equilibrium. Then we will learn about the kinetics of the reaction. See, we have both kind of compounds, which is organic compounds also and inorganic compounds also. Now, let's suppose if I am doing any chemical reaction, then I want to study how fast or how slow the reaction is. Then all that constitutes the part of physical chemistry. So all those things we will be learning in the physical chemistry, like how fast or slow is the reaction, what is the thermodynamics of the reaction, that is whether the heat is evolved, whether the heat is absorbed, or how the system is changing with the change in the temperature. And So these are the chapters that we will be learning in the physical chemistry and many more. And in the analytical chemistry, obviously, it is all the practical aspects that we will be learning, right? For example, the titrations, or how we purify the compounds, how we characterize the compounds. So all of those things we will be learning in the analytical chemistry. So this is how we will be learning the chemistry. And the first thing that you should know is we will be learning everything about all these elements which you are seeing in this periodic table. So if you know, it is good. And if you don't, that is also fine, like how the periodic table is divided. So this is a quick revision for those who don't remember, that this is the S block, this is the D block elements, and these are the P block elements. And here we have the F block elements. Now in whole of the chemistry, I'll be learning how these elements, they are existing, what compounds they are forming, and what is the behavior that they show depending upon how they exist in nature or the compounds that they form. So I hope now you have a good idea what exactly are we going to learn in chemistry and what are the units that we will be learning about. Now the first question that remains is, how do we define this branch of science, that is chemistry? So what we can say now is that it is the study of matter. It is the study of matter and the changes that the matter undergoes. So what I can say is that chemistry is the study of matter. It is the study of matter and the changes it undergoes. So in whole of the chemistry, now we will be focusing what is matter and how is it changing and what are the different compounds that are around us, so that now you can relate these things with whatever is happening around you. So after learning this subject, you will be able to relate that to whatever reactions that you can see outside, right? Now, when I say that it is the study of matter, so the first question that comes to our mind and the first thing that you have to do is we have to define what is matter. Now, these are the things which you might have learned in 9th and 10th standard. So I am hoping that you know what is matter. So quickly write your answer in the chat box. What is matter? So we'll do a quick revision of the basic things that you might already know. This is the chapter that you have learned in 9th standard, matter around us. So how do we define matter? Yes, you have to be very quick. Yes. So, yes, Bhavna wrote that the one that has mass. So I'll pick your answers and I'll write it here because these are the basic things that you should know. A substance with many types of particles have a specific mass and size. Yes. So now I'll tell you how do we define matter. So matter is anything, it is anything that occupies space and has mass. Now, what are the examples of matter around us? The pencil I am using, right? The chair you might be sitting on, the clothes we are wearing, right? The specs I am wearing, right? So these are all the matters around us. So almost all the things we can consider as matters, right? So we can give so many examples of matters around us. So just quickly give some of the examples of matter. So anything which is occupying space and has a mass. Now, here we will see how we are classifying matter. So matter can be classified in two ways. First, classification is based on the physical state. So the first classification is based on physical state. Now, these are the introductory things which you already know. So we will do it very quickly. So you have to constantly communicate with me and answer the following questions. So now, based on the physical state, we can have solid, liquid, and gas. Now, quickly define what is solid. Yes, I am seeing your chat. So you have to quickly answer this. What is solid? Okay, you have to define what is solid. So these are the substances that have, first one, fixed volume, and second is fixed shape. So in the similar fashion, we will define the liquids and the gases. So now liquids, do they have fixed volume? Yes or no? Yes. So these have fixed volume, no fixed shape. Whereas the gases, they don't have fixed volume, neither they have fixed shape. So that's how we will be defining solid, liquid, and gases. So for example, the pen that I am using, it is solid. Now, what does that mean that when I say that it has a fixed volume and fixed shape? So as you can see, it is having a fixed shape. If I try to break it, nothing will happen. It will remain fixed. Also, it is having a fixed volume. In this space around me, it will always be occupying this much volume only, right? The volume won't change, right? Whether I keep it here, I keep it somewhere else, or else if I give it to you. So the volume is going to remain the same. And here, the particles in solid, they are tightly packed. They are tightly packed. And in solids, these atoms, they can just move to and fro from their mean position. So they can just do like this. No other motion is possible. They are not free to move at all. So their position is fixed, and that is the reason they have the fixed volume and the fixed shape. So here the particles, they are tightly packed. So particles, they are tightly packed. Now, how does a liquid look like? So now, if I take these particles little away from each other. So now I am taking these particles little away from each other. And that's when I'll be getting the liquid. Now, there is strong force of attraction between these particles in solid. Also, there will be a certain force of attraction in this liquid also. And because of that, they will be having a fixed volume, because still they have certain force of attraction between them, but they will not have any fixed shape. What does that mean? It means here it is present in this beaker, right? So right now it is present in the shape of this beaker. Now let's suppose if I'll transfer it into a container which is a cube, right? Which is a cube. Now this liquid will take the shape of this cube. Similarly, if I'll transfer it to a bowl, then it will take the shape of the bowl. So here I'll say that it is not having a fixed shape, whereas the volume remains the same. How is it remaining same? If, let's suppose the volume here was 1 liter, even if I have transferred it to this cube, the volume will remain 1 liter. And the same will be true for when I'll transfer it to this beaker. So don't get confused between these two things, that is about the volume and about the shape for liquids. They have the fixed volume, but they don't have the fixed shape. Now let's come to the gases. So what are we saying for gases? We are saying that they don't have a fixed volume, and also they don't have a fixed shape. Now what does that mean? Let's suppose if I take a cylinder. So the drawings are not accurate, but just assume that it's a cylinder, right? So let's suppose if I have any gas in this cylinder, so what will happen is these molecules, they will occupy all the space that is available to them. Now, what I did is I compressed this gas. So this piston, let's suppose this is a piston, and I can press it. Now what will happen? Let's suppose the total volume here was this, the volume of this cylinder was 1 liter. Now I have pressed this gas and the piston comes here. So what will happen here? As the molecules, they were far away from each other, they will come close to each other. And here now the volume, let's suppose I have pressed it and made it to half. So now the volume that it is occupied maybe will be 500 ml. So depending upon what space I am keeping the gas in, it will occupy that much volume. Let's suppose if I transfer this gas to a balloon, then what will happen? It will occupy all the space that it will have inside this balloon. So the volume is not fixed for the gases. They will occupy all the space that is available to them. For example, let's suppose I take this cylinder and I open it in your room, the room that you are sitting in, then what will happen? They will occupy all the space that is present in that room. So now the volume has increased so much. So here for gases, the volume is not fixed. And also what you can see here is they don't have a fixed shape. They don't have a fixed shape. If I'll take them in a cylinder, they will take the shape of the cylinder. If I'll take them in a bowl, they will take the shape of the bowl. If I'll take them in a balloon, they'll take the shape of the balloon. If I'm keeping the gas in the room, they'll occupy all the space in the room and they will have the same occupancy. So that's the fundamental difference between the solid, liquid, and gases. So here the particles, they are tightly packed, and here the packing is little loose as compared to solids. where here the particles are completely free to move around. So just tell me if this topic is clear. So then we will move on to the next classification, which is based on the chemical characteristics. So this was a very basic topic which you, so just tell me in the chat if this topic is clear. So that's the fundamental difference, and that's the story of the solid, liquid, and gases. Simply whatever you can see on the screen, that's the thing which is happening with solid, liquid, and gases. In solids, the particles are tightly packed. They are loosely packed in liquid and very loosely packed in gases. And the thing that you have to remember is about the fixed volume and about the shape, because the thing that may confuse you is the question related to the volume and the shape of the liquid and the gases. So keep that in mind, that the liquids, they have the fixed volume and they don't have any fixed shape, whereas the gases, they will not have fixed volume, neither they will have the fixed shape. Now, let's quickly move on to the classification which is based on the chemical characteristics. So this is the classification which is based on chemical characteristics. So in that, we can have elements, compounds, and mixtures. And the elements and compounds, they are known as pure substances. Now, the thing that we have to understand here is what is elements, what is compound, and what is mixture. And the other thing that I wrote here is pure substances, right? And what does that mean? So now tell me, how many of you know what is element, what is compound, and what is mixture? Because these are the topics which you might have learned in your lower classes. So yes, quickly tell me what is compound, what is element, and what is mixture. Mixture, we'll see. Just quickly tell me whether you know what is compound and what is an element. And then I'll tell you what exactly they are. So your whole focus should be on understanding the things. So if you are able to understand it well, automatically you will be able to make somebody understand it. You will be able to explain it if you understand it well here in the class. So your focus should be on understanding whatever is being told. And then afterwards, you can focus on making notes and everything. Yes, what's an element? So here we'll again come to the periodic table. So now take a look at this periodic table. So what do you say when you look at the periodic table? So these are all the elements in the periodic table. What are these? These are all the elements in the periodic table. Now, let's suppose if I say you oxygen. So the first instinct that comes to us is we'll say, okay, that is O2. If I say you hydrogen, then you say, okay, you never say it is simply H. What do you say? H2, right? So now, how do we define elements? So elements, they are defined as pure substances that have only one kind of atoms, right? The definition is very, very important. You must know how do we define elements. So elements, they are the pure substances that have only one kind of atoms. And the other additional point is these atoms, so here the particles here can exist as atom or molecules. Yes. So these are the pure substances that have only one kind of atoms. What does that mean? It means, let's suppose I say you hydrogen. So how do we write hydrogen? I write it as H. So I have lot of H with me. Now this hydrogen, how does it exist? The pure element will exist as a H2 gas. So here, if I say you that I have a cylinder which is having hydrogen, now the smallest particle in that cylinder will be H2. So that cylinder will have the molecules of H2. So one H will combine with the other H and I will get the H2 molecule. So this is the element. Now here, the particle, it can exist as atom or molecules. Now, what are the elements in the periodic table that will exist as atoms? So there are only one. There are these, the examples of these can be noble gases or the metals, right? So here in elements, the constituent particle, it can be a molecule or it can be an atom. For example, I take helium, right? So here, the particles that are constituting this helium, they will be atoms. But the important part is that it's a pure substance which is having only one kind of atoms. So in hydrogen, even if two hydrogens have combined with each other, but there is just one atom that is present throughout the cylinder, which is H. Similarly, there is just one kind of atom that is present here, which is helium. Right? Now, quickly, we will move on to what is compound. Now, how do we define compound? I hope now you all know what are the definitions for elements and compounds, which I can see in the chat, that most of you know how do we define these terms, which is element, compounds, and mixtures. So, how we will define element? So, element, they have only one type of atom. So these are the pure substances which have only one type of atom, and particles here can exist as atoms or molecules. In the similar way, how do we define compounds? Compounds, they are also pure substances. This is very important for you to know that both of them are the pure substances. And in compounds, here two or more atoms of different elements, they combine together in definite ratio. So this should be ratio, right? So how do we define compounds? Here, two or more different atoms of different elements. The elements has to be different. Now, what could be the probable examples? For example, if I have H2O, if I have CH4, if I have CO2, right? These all are known as compounds, NaCl, right? So these are compounds. For example, glucose is C6H12O6. So what we can see here is that we have different atoms in this and they are present in a definite ratio. For example, here the ratio of hydrogen and oxygen is 2:1. Whereas in carbon dioxide, the ratio is 1:2. Here the ratio is 1:4. So the ratio has to be definite. Then only we will say that, okay, I have this particular compound. And these are also the pure substances. What does that mean? Let's suppose if I take a glass of water, then what I'll have in that glass of water? I'll have H2O molecules. Just only one kind of molecules will be present there, which will be H2O. No other compound will be present in that. So compounds are the pure substances in which two or more atoms of different elements combine together in definite ratio. So that can be two elements, as you can see here in water, methane and carbon dioxide, and it can be more than two elements also. For example, in glucose, we have carbon, hydrogen, and oxygen. So I hope these definitions are clear to you. That is for the pure substances, which includes elements and compounds. So here, if somebody asks you whether hydrogen is an element or a compound, you will say it's an element, right? Where it is existing as a diatomic molecule. Whereas in compounds, we will have the two different kind of elements. And in mixtures, what do we have in mixtures? We have two different kind of pure substances that are mixing with each other. So in mixture, what we have two or more than two types of pure substances. For example, let's suppose if I take a glass of water, right? And I put NaCl to it. So here I am having water and I'll put NaCl to it, right? So in that case, I'll have a mixture. Now, in the similar fashion, if I take a glass of water and I put sand to it, this is also a mixture. Now, what's difference between these two mixtures? So in chemistry, we have a specific term to define or to distinguish these two different kind of mixture. That is, this is a homogeneous mixture. This is homogeneous mixture and this is heterogeneous mixture. So the word in itself tells us about how they will be defined. Homo means same, right? What does that mean? So let's suppose if I take water from here, or if I take water from here, or if I take a look at water from here. So all of them will be having the same composition irrespective of from where I am taking this mixture. Whereas if I take sand, then what will happen here? The sand, it will settle down at the bottom of the glass. So if I take water from here, so maybe I'll not have any sand particle at all. And if I'm taking a mixture from here, then here I'll see that yes, along with water, I'll have some sand particles also. So what is happening here? That the composition is not same throughout the mixture. So that's what you have to write for the heterogeneous mixture is that the composition is not same throughout the mixture, whereas here the composition is same throughout the mixture. So that's how we define homogeneous and heterogeneous mixtures. So you can add it here that we have two types of mixtures, that is homogeneous and we have heterogeneous. And how do we define them? The one that is having the same composition throughout is the homogeneous. Homo means same. Hetero means different. So the one that is not having the same composition throughout are defined as the heterogeneous mixture. And the best example around us, can anybody give me the example of homogeneous mixture around us right now? And the one other point that you can remember for homogeneous mixture is that they will be in the same state, right? Yes, the air is the best example. So whether I take air from here, sitting here, wherever I am, or if I take the air sample wherever you are sitting, so the composition remains same, right? We have 21% oxygen, and then we have nitrogen, and in very trace amounts we have other gases. So air around us is the best example of the homogeneous mixture. And what are the other examples? If I mix anything in water, let's suppose if I mix sugar, if I mix salt, or if I put a ink, then after a while what you will see is that the whole of the water acquires the same blue color. Now, irrespective of from where I am taking the mixture, it will have the same composition. And the examples of homogeneous mixture is solutions. So how do we define solutions? Solutions are the homogeneous mixture which may have one or more components. So whatever we are mixing together, they will be known as components. That is, here I was mixing water with NaCl. So both of these will be known as the components. So these are some of the basic things which you are supposed to know before going into the depth of other topics. That is, what is the matter? Because basically chemistry is understanding of this matter around us. So we should know how do we define matter, what are the types of, how do we classify the matter. So matter, it will be classified on the basis of physical state. So we can have solid, liquid and gases, right? So also we have other states of matter, but we are not required to study them here, right? Plasma and one other more state of matter. And on based of chemical characteristics, we can categorize matter as pure substances and mixture. In pure substances, we have elements and compounds, whereas then we have the mixtures, which are formed by the combination of two pure substances. Now, can you give me the examples of mixtures? Some more examples of mixture. Alloys, right? Brass and bronze that we have around us. So decorative items that we have in our houses, right? They are sometimes made up of bronze, right? So all of the alloys are the examples of mixtures. So I hope this thing is clear to you, like how are we classifying the matter, and these are some of the basic things. So that's why we are covering it very quickly. And then we will come into the topics which we need to learn in depth along with the questions. So yes, quickly tell me whether you have understood this topic, which is the classification of matter. Yes. So the story begins with understanding what a matter is. Then we learned how do we classify matter. Now the next topic that we will be learning is in the next class is once when I know what matter is, how do I classify it? Now the next thing is to learn about the properties of matter and their measurements. Now when we say properties, so let's suppose if somebody gives you something which is brought from moon, let's suppose some stone which has been brought from moon. Now I want to learn everything about that stone. So what I'll do is I'll see what are its physical properties, and along with that I'll see its chemical properties, so that I'll understand what exactly that particular stone consists of, right? So now we will see what are the properties of matter and how do we measure them. So in properties, we will see the physical properties, and secondly, we will learn about the chemical properties. So whenever you are in lab, then if somebody is asking you to tell all the things about a particular matter that you have, then in that case you have to find out, you have to study both, that is the physical properties and the chemical properties. Now these are the things that we will be learning in the next session, like what are the physical properties and what will happen to the matter, or what are the properties that we will be measuring, so as to understand the properties of matter. Whereas in chemical properties, as the word is, what we will do the chemical reaction. Here in physical properties, we will not be doing any chemical reaction. Simply, we will be doing just the basic measurement, which may include measuring the length, measuring the weight, measuring the temperature, measuring the density. So there is no change in the composition of the substance here. Whereas in the chemical properties, what will happen? The substance will change. It will react with something, and then I am going to get the some other substance. So chemical properties basically includes when I want to know about the acidity, basicity, combustibility of the substance. And in the physical properties, what are we doing? We are measuring the length, weight, temperature, density, viscosity, melting point, boiling point. So all of those things are which comes under the physical properties. So here, now in the next session, we will be learning about the properties of matter and their measurement. And in that, we will see the physical properties and the chemical properties. And our focus will be on the physical properties. So in next session, what we will do, we will see what are the physical properties, their units, and what is the system that is used for measuring this physical properties. So here in this particular session, we have just gone through the basic things which you already knew. That is, what is the matter? How do we classify the matter? So it was just a quick revision for the things that you might have learned in 9th and 10th standard. Now from the next session, you will be learning about the new things, which includes learning about the properties. And then finally, we will learn about the other topics, which includes the mole concept, stoichiometry, limiting reagents, learning about how do we specify the concentrations, right? So these will be the new topics for you, which we will be learning in the coming sessions. So I hope all the things are clear to you. If there is any doubt, you can ask. So here I'll pick some questions which is asked, like Bhavna is asked, what if atom of same elements which easily makes it homogeneous, not mixed it? Okay. So Bhavna, what exactly your question was? What if atom of same elements? So if there is any doubt, you can ask. If not, just give the thumbs up and we'll end the session. Okay. Coordination chemistry. Yes, coordination chemistry is basically, so see what I have told you. This is the periodic table that we have, and we know these are the elements that exist in nature. Some are existing naturally, some are man-made, right? Now, in whole of the chemistry, I'll be learning about their particular properties, which is basically learning about their elemental forms. And then I'll see what are the compounds that they are forming, right? Now, the coordination compounds are the compounds which will be formed by these elements with the other elements. That is, the compounds that are formed by the D block elements. Which these D block elements, they are also known as transition elements, because here I am transitioning from S and then D is coming and then I am going to P. So it's like a transition from S to P. So the compounds that will be formed by these D block elements, right? So they'll not be having these organic compounds, right? So compounds that will be formed by the D block elements with other ligands or other elements, those will be studied in the coordination compound. So here we will have a metal and then others will come and they will coordinate with that metal. So coordination chemistry is basically learning about how do they exist, what is their color, what is their properties. So, or the chemistry of the compounds that are formed by the D block elements is what we will learn in the coordination chemistry. So I hope this is clear to you. Okay, I think there is a doubt about compound and mixture. See, if I take an element, then in element, let's suppose I said, okay, I have hydrogen. So now, if I say hydrogen, then hydrogen, how does this exist as an element? As an element, it exists as a diatomic molecule. How does it exist? It exists as a diatomic molecule. Now, what are the other elements that will be existing as the diatomic molecules? We can have O2, we can have Cl2, we can have Br2, we can have I2, right? So these are some of the elements which will exist as the diatomic gas. So now let's suppose if I take a cylinder and I say you that there is hydrogen in it. So we will have hydrogen, but now here the constituent particle is a molecule. This is element. What is this element? Hydrogen. And in this hydrogen, what is the constituent particle? It is the hydrogen molecule. And what I can see here is that all the atoms are same. We have hydrogen, 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 and hydrogen. Now, let's suppose I say you that I have a beaker and in that I have water. So water will be oxygen attached to hydrogen. So in compounds, throughout this water, whatever water I have with me, all of the molecules will be having the same composition. That is, the hydrogen has combined with oxygen in 2:1. And throughout this glass of water, I'll have the same kind of molecules where two different elements. The condition is the element has to be different. Two different elements, they have combined in a fixed ratio. And that's how I get the compound, which is water. The same thing will be true for CO2 or any other compound, which may be glucose, which may be methane, ethane, whatever. You can pick any molecule, right? So in compound, what is happening is two different elements are coming and they are combining with each other in a definite ratio, right? For example, in NaCl, what do we have? We have Na and we have Cl. Now, if I take this water and I take this salt and I put them together, now I have got a mixture. What I have got? I have got a mixture. What I did here, I took two pure substances and I have mixed them together. Now they can be mixed in any proportion. It can be 2:1, 3:1, 2:3, 1:4, 3:4. So the proportion can vary in a mixture, right? So here we are taking two or more pure substances and then they are mixed together with each other. Whereas in the compounds, the element has to be different, but yes, they will be combining in the definite ratio, and within that substance, we will have the same kind of molecules. So that's how we define the compounds. Yes, combination of same elements is a molecule. Combination of a same element is a molecule. And the combination of different element is a compound. Yes, Bhavna, you are correct. That's how we will define it, right? I hope now the difference is clear between how do we define elements and how do we define compound. So if I'm combining both the elements, then I am forming a molecule. This is also a molecule, right? This is also a molecule. This is also molecule of water. Correct? So this definition which you wrote, that combination of same elements is gives us molecule. Yes, that is true. But the combination of different elements will also give me a molecule. It can also give me a molecule, right? Is there any other doubt? Yes, ma'am. So I think,
Yes, ma'am.
yes, the session is over.
Okay,
So
okay,
the
ma'am.
students, they don't
Yes,
have
ma'am.
any doubt for now. And if there
Okay,
is any other doubt, I'll clear in next session.
okay, ma'am. Sure, ma'am.
Yeah, okay.
Yes, ma'am. Thank you, ma'am.
Yes.
Yes, students, I hope all of you have understood today's class. If you have any doubts, you can message to the WhatsApp number 733-7285-228. If you have any doubts, you can WhatsApp to 733-7285-228. And also again tomorrow we will meet at the same time, that is 7 to 9 p.m. Right? So bye everyone. And also subscribe to our channel Jatadhara Educational Technology. Yes, bye students.